So there's a big difference there in what you're doing. It's not a direct recharge issue. And oh, by the way, they don't have some of the options we have. Meanwhile, we're in the Netherlands. Okay? There are a series of problems that are identified with the reuse answer, and yet the issue with climate change impacts is not one of the issues that's discussed there. We're going to come back to an example of why this is. And there are huge costs associated with this option. And there's lots of golf courses that really don't like reuse. So here's a potential climate change problem. You can probably hear me well enough to do this. Okay, this is what we kind of created. All right, so we've gone ahead and we've created this urban area for all the half the people on this side of the room that all lived on the other side of the hill. And yet, when we go ahead and start increasing water levels, so we'll take the 88 inches or 3 foot or something like that. I don't do metrics, so 88 inches is what we're going to talk about here, or excuse me, 3 feet is what we're going to talk about here. What happens is, if you're at elevation 5, you suddenly have 0 soil capacity. And what that means is when it rains 1 inch of soil, we kind of figure, just as a rule of thumb, in the sand that for every foot that you have that's not saturated, you can probably put 1 inch of rainfall in there. So, you know those afternoon rainstorms that we have that dump 1 inch of rain on it? If you have 0 storage capacity, guess where it sits? In your yard. And then you call the utility and say, you know, my yard's flooded. Please come clean the storm drains. Or better yet, in Hollywood, I worked in Hollywood for a while, there are fish in the street. There's fish in the street. Okay, now, you know, that was it, you know, today, and just because it happened to be, you know, that October high tide that was 2.5 feet, and then fish came up the drain. Okay, so you can see this creates a problem. So now we're going to think about, well, wait a minute, let's go ahead and artificially put water on the, you know, that area, the urban area there, right? So what the point of this is, there are short-term issues that people start to look at in trying to come up with water solutions, but there is a longer-term reality that sits there that you're going to invest billions of dollars on. And yet the short-term issue may exacerbate a longer-term problem. And if you look at this, you start saying, well, what is the solution to the poor guy that lives right here? Because even though I've drawn this relatively flat, as you say, it's not exactly flat. It really kind of is going that way. So the guy that lives against the dike, that 1 inch of rain kind of turns into sweet water. Okay, and now you're trying to figure out, what do I do with all the water in the front yard? And he's saying, wait a minute, it has fertilizer in it, and I don't really want to feed it to the ibises or the alligators. I don't want it in the park. But the reality is, it wants to go that way. And what we've done is we've modified Mother Nature to suit its ends, and she's about to strike back. So let's talk about technologies to adapt. One of the things that Jim and Barry and I have been working on in this project is there are a variety of things that we can look at. And we're going to stay in the adaptation mode because we're going to think positive, and you know, we're not going to get, you know, that 16-foot rise, which, you know, somebody put out there once upon a time. I'll show you that picture. But here's the things we can look at. One is relocation of wells. But relocation of wells actually may be a different issue. Number one is, if you live on the west side, you may be pumping all day, every day, just to keep your aquifer levels down, and that sounds like a Biscayne raw water supply to me. It really does. He doesn't want it in the dike, but we can drink it. So all of a sudden, the rule to no more Biscayne water, we just re-thumped that. Okay? We're looking at a couple of projects myself on horizontal wells because we could go skim along the coastal area. So think about it, if you are in the eastern part of the county, you are downstream of any salinity structures, and what we find is that we have a freshwater lens that's 30 to 50 feet. If we could skim off that, that would be useful, right? Because the rest of that water just goes merely on out to tide as part of that 20 billion gallons a day. So there's water that we could capture that way. Regionalization is helpful, I guess, if you're a small utility, and yet if you look at the horizontal capture thing, a smaller utility might take advantage of that, where a larger one wouldn't. We can go to desal, and I would suggest that between desal for oceans and desal for all of Dade County's reuse plants that they're going to do out there, there's a reason why they're building a new reactor at Jerky Point.
Yeah, to run the desal.
To read the desal plants, okay? We can look at coastal armoring, and what you have is a resistance right now to consider the idea of putting lock structures or salinity structures closer to the coast in southern Broward and Dade County. And I've listened to the folks in the legal team in West Palm Beach tell me that they were concerned about property rights. And the guy that lived out there in the dike, what's your property rights argument for that? We can help with that, okay? Artificial recharge, obviously options to do and transfer between regions. And again, this would be the issue that the guy on the dike suddenly has a reason to get rid of a lot of water supply. Moving back east looks like a good water supply option. And we may have rued the day that we're closing the outfalls. The canal recharge project looks like this, so if anybody doesn't know what reverse osmosis, advanced oxidation, and all that heavy stuff looks like, it's a whole lot of stuff. It's a lot of money, so that's the price that I was given for Dade County. Bertha can correct me if I'm wrong, but that's what I got. It's a lot of money that you're going to add to people's bills, and we have a huge carbon footprint for just about the time that we're sitting here saying, hey, we're concerned about climate change and we want to go mitigate that. We're going to do that. Clean technology called nuclear energy, right? All right. If you're a utility, you start evaluating these options. And the one that does not, and this is kind of, engineers do this all the time, we like to make these little matrices and we come up with options. And you come up with numbers and reuse never comes to the top. And in part because utilities look at costs. And then we look at, well, wait a minute, the plant is over there and you want us to put the water over there. And there's a whole bunch of infrastructure that needs to be done there. And there's a lot of issues and it's just not easy. So when we start looking at Florida and Aquifer, that sounds great until you start looking at the fact that that aquifer degrades with time, as it has everywhere else in the coastal area. And when what happens is now we have to change all the pumps and motors in our RO plant because the water's saltier. That's not necessarily helping us either. There could be a better option. This was discussed. Dan will like this one better. And that would be, hey, if you're going to go, if you really think ROing and recharge is a great issue, where was the recharge area for this aquifer? Everglades, okay. So maybe we ought to go ahead and try to put some of that water back into the Everglades that we're supposed to be doing anyway, and take the reuse to the dike and send it on over there and try to recharge that way with the canal system we have. That's a possibility. Could make some sense to try to do something like that. But realize that we're starting to talk about huge amounts of money that would need to be invested to try to deal with these supplies. So you're talking about, you have pump stations all along the dike. You're trying to do something with wastewater that's being created. You have a water supply that you're pumping out of the ground and sending somewhere. You're going to be going back and looking at Biscayne water supplies to do that. And this is completely, and putting box structures in, don't forget that. You're looking at something that's 180 degrees from the existing thought process in dealing with water supplies in South Florida. Everybody agree with that? It's completely opposite. We're saying no Biscayne, reuse everywhere. You know, don't pump anything around the dike. Okay? So what we're looking at is a complete change from an infrastructure perspective. So as we're looking at this project, we're starting to look at some case studies of utilities, and the issue that we start to look at is exactly this. You're going to spend huge amounts of money at some point in time, and the question is, how do you pick the point in time when you make that infrastructure investment? Is it 1 foot of sea level rise, 2 feet, 3 feet? Okay, if it's accelerating, you know, you might not want to wait till you get, you know, like a week or two before it happens. Okay, you're not going to, this is not going to become New Orleans. Okay, a couple 100 miles of diking, there's not helping, because what's going to happen is, this is the recharge thing, that comes out to be a better idea. But what's going to happen is you're going to find out as sea level starts to rise, his issue with Biscayne aquifer floating up starts to look like this. This dark blue is, if we're 5 feet higher, what is that potential inundation? That's a NASA map, it's not mine. Everything in blue is less than 15 feet above sea level. Okay? So what starts to happen is, go back to, as sea level rises, I suddenly start to lose the ability to store water in the soil. I've got all these issues about trying to move water around somewhere. And the reality is, these are all places where you have really no capacity to put water, or to sprinkle water, or to recharge water, or to do something you're actually trying to extract it to go back and keep it down. And this is another map of the issues. So, any questions about all that good stuff? See, I even got the 2 minutes.
You did. Yeah. We're going to take questions from the panel. Thank you.
Thank you.
So you can see, you take the policy from the federal to the state to the regional down to the specifics of issues like Brett talked about. We've got challenges out there. And I think at this point, Jaap, should we entertain questions for both panels? Where's Jaap? You would? Anyway, we'll take questions for both panels. I think we have with those folks here. Yes, sir?
I have a comment on this presentation regarding putting water into Everglades. I wish it was as easy as saying let's put it into Everglades. And there's a lot of constraints to some of the things that you're proposing. I'm looking at it from the water supply side of things. When we manage water, we've got water quality constraints, environmental constraints, with flood control issue as well. When you talk about water supply, I was hoping you would talk about some of the challenges in balancing water supply with the other stressor on the system, which is really what is limiting the South Florida Water Management District in doing some of the great ideas you have. I wish we had carte blanche to do a lot of that stuff, but the reality is they have a lot of conflicting needs for that water. Can you comment a little bit just on some of those constraints and how they interact with each other?
Yeah, in a 20-minute, now 10-minute presentation, despite that, you have a really cool picture of a shark. So I fit all my ocean friends with like, I took that picture. It was an aquarium. Or maybe not. But anyway, going back to your question, yeah, there's a huge amount of conflicting issues that need to be dealt with. And if you're going to look at climate change issues on top of trying to manage the supply, and there's a lot of arguments about whether it's properly managed or overly managed, and there's water quality issues from all over the place as far as what's coming in from ag, what's seeping underneath the dike, what goes back over the dike. And I agree with you, there's limitations on just dumping it back in the canal. Sounds really easy, but even with reverse osmosis, it's not easy. All of those are challenges that are out there, and it's not quite as simple as a 10-minute presentation would make it. It's more, what we really probably need to be doing is looking outside the current philosophy, because the longer term strategies probably say that the current methodologies that we're going to need to be revisited, because they're not going to work. If you're going to if you're going to see a 3-foot sea level rise, let's just say by 2100, and you have no soil capacity, you can't put 1 million gallons a day on a golf course. Pure and simple, it can't be. So if you're relying on utilities, okay, to go ahead and get rid of their wastewater by irrigating golf courses, that suddenly is no longer a disposal option. So what are we doing with the water? And what you find is that while we have limited areas that we can do this, that becomes less and less of an option. Even to the point that, and this exists even with the district. Okay, even within your organization, some of the folks are saying that going 50 years out, if you start to see this kind of change, then the district's going to have to revisit its whole pumping philosophy, because water levels will rise, and you're going to turn around and reverse some of the issues that you brought up today, to deal with drought issues. All right. So we need to keep in mind that we do a lot of really short-term planning, but the sea level rise thing could be long-term. And if you get to a certain point, this is not an issue that's solvable. I mean, if you get 16 feet of sea level rise, which is a really crazy number, but you get that we're not living here. None of these issues really matter at that point.
Bertha had her hand up. You mentioned Bertha, so I give her a chance to respond.
Well,
Bertha, you want to identify yourself? I'm sorry.
Yeah, Bertha Goldenberg with Miami-Dade Water and Sewer Department. Fred mentioned about all the reuse that we're doing, and that's true. We're implementing a number of alternative water supply projects, which is a requirement for a 20-year water use permit. But in addition to that, we're going to be doing more reuse because of the outfall legislation, which requires we don't use the ocean falls anymore after 2025. So by 2025, we need to implement 254 million gallons per day of reuse. This week, for one of the county's climate change task force, the Energy and Building Subcommittee, we were asked to calculate how much energy we're going to be using with all our projects. And our preliminary estimate is that we're going to triple our energy usage by 2025.